Welcome to the AP Physics lecture on dynamics. Here we're going to cover the normal force. The normal force is, by definition, the normal force is associated with the surface, but how does the surface create this force? When you lie on a mattress like this, your weight causes the spring to compress. So these springs are going to push down. As they compress, a force develops in each spring that pushes back. So that's going to be the resulting force that pushes back due to Newton's third law towards the original position up. When a box sits on a floor or on a table, it compresses the intermolecular forces between the molecules, in a manner that is similar to compressing the spring in this mattress. So this compression, think about it like atoms. The compressed intermolecular forces act like a spring that pushes back against the weight of the box. That is, by definition, the normal force. It is the total upward force of all the compressed intermolecular forces acting together, creating the normal force. The normal force can be seen in two ways. You're going to see it either on a horizontal surface or on a ramp, but it's always touching a surface because of the molecules on the surface. Why is it called a normal force? Well, in geometry, a normal line is a line that is perpendicular to any object. The force created by a surface is always perpendicular to the surface. The normal force is called the normal force because it is perpendicular to the surface. Exactly like on the ramp, this force here is perpendicular. There's no specific formula that solves for the normal force, but it behaves in two ways. Okay? The normal force in the horizontal case, the normal force is equal to weight, m times g. But here, when it's on the ramp, you see that the normal force is mg, but it has the cosine theta part that comes as a result of the cosine part of the force of gravity here. The normal force is situation dependent, and the equation that will be used to solve for it will vary from problem to problem, but there's only two cases for it. The next questions are conceptual multiple choice questions to check your understanding for the normal force. 1. A book is at rest on top of a table. A student makes the following claim. An attractive electromagnetic force is exerted on the block from the table, and this force can also be classified as the normal force. Which of the statements correctly justify the student's claim? It would be C. The claim is actually incorrect because the charged particle of the table exerts an upward. So it's upward because here it says the book, when it's at rest on top of a table, it's on top of the table. So it's right now it's going to be book on table. So there's going to be an upward force going from the book table to the book. The claim is incorrect because the charged particle of the table, right there, table, exerts an upward force on the book. So table right here on book. Okay? That's why the claim is incorrect. This is due to Newton's third law. Number 2. Here you have two bricks are stacked on the floor. A student draws the force diagram on brick 2 as shown above or below. The force are an upward normal force, Fn, a downward force exerted by brick 1, F1, and the downward force of gravity, Fg. How many forces, if any, in the following diagram are contact forces caused by the molecular interaction? The only force that is a microscopic interaction is going to be the normal force, and that is going to be only 2, which is going to be the normal force. Okay, and then it's going to be the down, right, and the opposite of it, down by gravity. Yep, right here. and F1. Okay, remember this FG, this is a long range force, so FG doesn't count. It's Fn, normal force, and F1. 3. A box slide to the right on a rough horizontal surface. The force exerted on the block are shown below. Which of the following statement about the frictional force, F of F, exerted on the block is true? The sum of all the microscopic contact forces between the bottom and the block and the surface. Okay? The force of friction, by definition, force of friction, F is equal to mu times N. Okay, this is due to the microscopic, right, block and surface. Okay. There are 2 example problems that you can work on. Example 1, determine the normal force on a 10 kilogram mass at rest on a horizontal surface. And 2, determine the normal force on a 10 kilogram mass at rest on a horizontal surface while a rope pulls upwards at 30 newtons. So here's the first problem. You want to assess this. We see that the object is going in the upwards direction. So it is stationary, right? Because it says at rest, so A equals to 0. So this is why it equals to 0. Here's the diagram. Notice that the length of N is equal to the F of G. It has to be the same length. Now you do the sum of the forces. What are the 2 forces here? N and FG is going down because anything up and to the right is positive. So FG goes down, so we write minus FG. Then what we're going to do is we're going to add FG to both sides. Okay? Therefore, you have N is equal to mg. Mg just comes from force of gravity. Makes the substitution here, you get the normal force equal to 98 degrees, 98 newtons. This makes sense because if the force of gravity down here is 98 newtons, for it to balance, there has to be an equal and opposite force here that is also 98 newtons. Example 2. Determine the normal force on a 10 kilogram mass at rest on a horizontal surface while rope pulls it upwards at 30 newtons. Like the last problem, this object is stationary because it says at rest. So the summation of the forces in the y direction equals to 0. The diagram here shows the normal force pulling it up and the tension force also pulling it up. The only force that is pulling it down is the force of gravity. So there's something a little bit wrong with this picture. The correct picture would look something like this. The force of gravity is long, like this, okay? The force of do you see how it's this long? Okay, so for it to be at rest, the forces also have to be this long as well, equal in size, right? But there's 2 of them, so I have to split it in half. This is going to be like the normal force, then this is also going to be the tension force, okay? Because these 2 have to balance the force of gravity. This would be correct, all right? So make sure that the lengths are correct. On the free response, the AP College Board is very picky about this. So if you do the summation of the forces here is N goes up plus T goes up minus FG. The summation, the MA here goes to 0 because the object is at rest. Now we do the algebra. We add FG to the other side. So add FG, subtract T, subtract T. That's how you get N is equal to FG minus T. So substitute mg for force of gravity and tension in there. Plug it in, you get 68. Okay, this makes sense because if you drew it here, the force of gravity, just gravity by itself, is 98 newtons, right? This is gravity. So the two forces here have to add up. So the force normal is going to be 68 newtons. So this one has to be what? Okay, slightly smaller. So I think it's 30 newtons. Because here, they add up to 68 plus 30 newtons would be, 98 newtons. So this is how it would look like. Okay? The normal force is 68. The tension force is 30 newtons. All right? But there you go. These are your two cases for the normal force calculation.